Hello, I have created a project called Camerata Orchestrator, and the purpose of this project is to create rules and directives for AI agents to follow as they work on your coding and development tasks. AI can be quite untrustworthy when it comes to not hallucinating code, architectural drift, things of that nature. So I've created a process that helps prevent those things from happening. What I'm going to show you today is the first phase of this, which is now finished end to end, and that is the onboarding phase. So I'll begin by creating a project, and I will create and open, and you'll see this is the project workspace. Onboarding repos, this is the phase I'm going to show you today. And what it does is it will scan a set of repos that you select, or it will create everything from scratch in a green field. But today I'm going to show you what it does to existing repos. So what it will do is it will do a quick scan first, see what frameworks you have, what languages you have in the repo, and it will make recommendations for what rules to apply. You'll see those rules in a table, and you can select the ones that you want. You can deselect any of the recommended ones. You have total control to customize that. After that point, it will then do a deep scan of the repos against those rules. And what will happen is it will pick out any violations to those rules and then present it to you in a table. And from that table, you can select what to do with them, whether you want to ignore them as a flag, or if you want to create a tech debt story and work on it. So I will show you by first selecting two repos here. For the sake of token expense, I'm going to be choosing repos that I created that are small. So as you can see, I've loaded in two repos into this project. For the record, one of these is a full stack TypeScript application, and one of these is a full stack Rust application. So what I'm going to demonstrate is that there are different rule sets for different stacks, and each one will get scanned against the selected rules for the stack. So first I'm going to scan here, and this is going to show you that it has now selected a set of rules that it thinks applies to each project. So Agora Mini, this one is the full stack TypeScript application that I had mentioned. And I'm going to show you what happens in this selection. So first and foremost, you'll see that I can't proceed yet because there are a couple of rules that don't have a default. Right now, the recommendations just select the default, but some of these are truly multi-option and there is no default. So I have to go in as the user and clear those out. So I'm going to expand all of these and show you one of those examples. So let's come down here. This highlighted one is the one that needs me to choose. So I'm going to open this up and you'll see this is what a rule looks like. There's a lot written here, so I'll leave it up to you to read, but basically what this rule is saying is that an AI might come across a code where it needs to write it and it needs to follow a rule, but the writing of that code would then be problematic within the context. So what I'm going to choose here is that if AI believes that it needs to override a rule for any reason, it's going to stop development and then give me the heads up, me as the architect of the project, right? So I'm going to select this rule in particular. That is my choice. There are alternatives that you can choose, so it's up to you as the user to choose those. Okay, and now as you can see, I have selected all the options for those rules. I'm just going to, for the sake of brevity, leave everything else to be the default, although it is highly encouraged that you read through the rules as the architect and decide which ones apply to your projects. Because a lot of them are left open for interpretation, a lot of them have defaults, but there are reasons why you may not want one of those defaults. So this is considered now rule set complete. So first I'm going to do this, add rules to repo, which is what this is going to do is it's going to place these rules as markdown files in each repository. And then it's going to push that code to my GitHub. And there, as you can see, it pushes the branches to GitHub, so I can manage those later on. Now I'm going to go for the next process here, which is the actual auditing scan. So right off the bat, we can choose what models we want for each step. So the audit model, this is the heavy one. This is scanning all the code. For this, I'm going to choose the cheaper model here. For the calibration, which takes the scans and calibrates it a bit, that I'm going to keep at Sonnet 4.6 as it's a little bit more thorough. So this is what it looks like. Gives you an estimated cost. It's going to tell you exactly what it's scanning. And the scan mode, there's 3 different options, and I won't go through each one. I'll let you read the documentation if you would like to see what the difference is. But basically, this is going to scan the code in the background on the server side of this application, and it's going to break it up. And you'll see what that looks like here in a second. So I'm going to go ahead and click Audit Code against these rules, and you'll see what happens. So it has now started the activity of scanning, and this is going to take at least a few minutes, so I'm going to speed up this part of the video. But just to show you a bit of what's happening underneath the hood, I am going to expand this. This is the agent activity, and you'll see this there will be more of these agents running at a time as things occur and as findings are found. So you'll see that happen here. It shows you the generated prompt. It shows you when it stops running. So I am going to speed this part up since this is going to take a bit of time. Okay, now everything has been scanned and calibrated, and as you can see, it shows the findings in the output as it returns to us in JSON format. I'm going to hide this now. It shows you the actual cost of running the agents, and I'll move on now. So these are the findings in this table here. So both repositories are included in this table, and we can filter by which repo we want to look at, but for the sake of brevity, I'll just expand all. And as you can see, there are different kinds of findings here. These are the critical ones. These are security findings here, and I'll open one just to show you what it was. So that's one example of a critical finding. That one is a deterministic finding. And then I'll continue down here. You'll see there's some highs, some mediums, there's some lows. And one of these I will show you. I need to find an example here. This is one that needs review. So what this is that it will apply the rule and it will scan the rule and it will also find the violation. But then if the agent believes that the rule is overzealous or maybe miscalibrated, it will actually tell you in the finding here. This one is an example of that. So I will close out of that. And what I am going to do here is show you what happens next. So I'm going to first filter this by severity. I'm going to take the mediums and the lows, and I'm going to select all of them and ignore them. And I'm just going to say, reason being, not a high priority. So then I'm going to ignore with reason, and that's going to move to the ignored table. So now all we've got left are the criticals and the highs. So let me go ahead and show you one of these. So this one is telling us here that the input of an endpoint is not validated. So this is one of the findings. And yeah, these are the types of violations it's going to find. So these are high and critical findings. So I'm going to select these and save them as tech debt. Tech debt folder is here, and you'll see the table that lists out all the critical and the highs that we brought in here. So I can fine grain this down even more. I'm going to select all the critical ones. And what I'm going to do with these is mark resolve now. And the rest I'm going to mark as resolve later, which they are by default resolve later, as you can see. The main difference is that in both circumstances, backlog story, in this case a GitHub issue, is going to be created for all of these that are marked resolve as tech debt. Resolve now, what that will do is once the next phase of this is built out, it will automatically bring in those stories to be developed. The resolve later will also create a story, but it won't automatically be brought in. It'll just be created as a story, so that way it can be refined and looked at later down the road. So I'm going to process ignored and tech debt buckets, and ignored creates a flag in the repos, so that way multiple scans in the future don't catch these items again. And now I'm going to create stories for the continuous integration rules. These are mechanical rules that are meant to live as part of your continuous integration. The actual adding of those rules in the repo is not done from here. That would be done by the development cycle. So I'm just going to go ahead and create the stories for these. And then once I'm done with all of this, all of the violations have been dealt with here and decided. So I'm going to go ahead and then complete the onboarding process. And now we are clean. This is what's going to show up next, the governed development cycle here. And what this will do is it will allow you to bring in stories and develop them using all the rules that you just applied. This is not yet built out yet, but this will be coming in the near future. Thank you very much.